Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Our chapter today is about limits. Now we saw in the previous part of limits that the first method of calculating a limit is substitution. Now we have another method which is the factorization method or the leading term method. If the calculation of the limit at infinity by substitution leads to one of the indeterminate forms, then try to use the leading term method. So this method is usually used when we are finding a limit at infinity and the substitution method leads to one of the four indeterminate forms. Infinity over infinity, 0 over 0, plus infinity minus infinity, and 0 times infinity. And the substitution is the first method of calculating a limit. We might get an answer in case we are using a substitution, or we might get an indeterminate form. So one of the methods in this case is the leading term method, and let's see what do we mean by leading term. Let's find the following limits. Now we need to find the limit as x tends to plus infinity of this function. Now if we substitute, we get plus infinity minus infinity, and this is one of the indeterminate forms. Now what do we do in such a case? We take in fact into consideration the terms that contains the highest power, which is 3x squared in this case, and the limit of the whole function would be the same as the limit of this term, which is in this specific example plus infinity, because we have 3 into plus infinity squared, which is plus infinity. Now let's see another example. In this case, if we substitute, we get plus infinity, which is positive infinity over positive infinity, and this is also an indeterminate form. So what do? We take the leading term in the numerator and the leading term in the denominator. So we get the limit of x squared over 2x, and if we simplify, we get the limit of x over 2, which is negative infinity. Let's see a third example. We need the limit of this function as x tends to plus infinity. Use the leading term because the substitution leads to negative infinity over positive infinity, which is an indeterminate form. In this case, we get the limit of minus 4x over 2x, because the leading term in the numerator is minus 4x and the leading term in the denominator is 2x. And if we simplify, we get the limit of negative 2, and the limit of a constant is itself. The fourth one, we need to find the limit of this function at negative infinity. We also substitute and we get positive infinity over negative infinity, which is also an indeterminate form. So we take the limit of x squared from the numerator and x cubed from the denominator. We simplify, we get the limit of 1 over x, and 1 over infinity is 0. Now try to do these applications, please. Try to pause the video, find the answer, and then compare your answer. Our next approach or method is the simplification method. Now, if the calculation of the limit at a point by substitution leads to one of the indeterminate forms, then try to use the simplification method. Remember this procedure. We have to substitute first. We might get the answer, or we might get an indeterminate form. In case we have an indeterminate form, we either use the leading term method or the simplification method. Let's see what do we mean by the simplification method. If we want to find the limit of this quantity, and this is the limit at a point as you see, if we substitute, we get 0 over 0. Now this is one of the indeterminate forms. We cannot in fact here use the leading term. We have to use the simplification method, which states that we try to factorize the numerator alone and the denominator alone. And in this case, if we factorize, we get 2 into x plus 1 in the numerator and x minus 1 into x plus 1 in the denominator, and then we simplify, and from here comes the name of the method. And if we simplify, we get the limit of 2 over x minus 1, and if we substitute negative 1 here instead of x, we get minus 1. Remember, even in the simplification method, after we simplify, we have always to go backward to the substitution method. Now let's see the second example. So when x tends to 4 here, we also get 0 over 0. So because x tends to a point, we try to use the simplification method. Now here, I'd like you to remember, please, the factorization of a second degree polynomial. If the second degree polynomial has two distinct roots, x1 and x2, then its factorized form is a into x minus x1 into x minus x2. Now, in this case, specifically, we can see that it is a second degree polynomial and it has two roots, which are 1 and 4. And if we want to factorize the denominator, we get a into x minus 1 into x minus 4. Now for the numerator, in order to factorize it, we just take x in common, we get x into x minus 4. And we can simplify x minus 4 and x minus 4 to get the limit of x over 2 into x minus 1. And if we substitute 4, we get 2 over 3. Now let's make a few applications about the simplification method. Now try to pause the video, find the answer, and then compare it with the given answer. The third method of calculating limits is L'Hopital's rule, and L'Hopital is the name of a French mathematician. Now, L'Hopital states the following. If we have f and g two differentiable functions on an interval I, and if the limit of f over g leads to 0 over 0 or infinity over infinity, then the limit of f over g would be the same as the limit of f prime over g prime. And L'Hopital's rule works if x tends to any real number or if it tends to plus infinity or to minus infinity. So simply, if the limit of a certain fraction leads to 0 over 0 or infinity over infinity, L'Hopital states that this limit would be the same as the limit of f prime of x over g prime of x. And x can tend to one of the two infinities or to any real number. Now let's see this example. We need to find each limit using L'Hopital's rule. Now what is the limit of this quantity? By substitution, we have to use substitution in order to see whether it leads to 0 over 0 or infinity over infinity or not. So if x is negative 1, we get negative 2, positive 2, which is 0. And in the denominator, we get 1 minus 1, which is also 0. So this limit leads to 0 over 0, so we can use L'Hopital's rule. L'Hopital's rule states that we derive the numerator alone and then the denominator alone. So this becomes the limit as x tends to negative 1 of 2 over 2x, and if we simplify, we get the limit of 1 over x, which is negative 1. One might ask whether we can use the simplification method or not. Of course, we can use the simplification method. And in fact, this is the same limit as the one that was given before in the simplification method slide. Now let's see the second example. We need the limit at plus infinity of this quantity. Now based on L'Hopital's rule, if we just substitute, we get infinity over infinity. And in case of infinity over infinity, we can use L'Hopital's rule, which states that we find the derivative of the numerator alone and the derivative of the denominator alone. In this case, we get the limit of 2x minus 4 over 4x minus 10. And again here, if we substitute, we get infinity over infinity, so we can use L'Hopital's rule again. We derive the numerator, we get 2, the denominator we get 4, and this becomes 1 over 2. In this case, we can also use the leading term method, and it might be easier because this is automatically the limit of x squared over 2x squared, which is 1 over 2. Now let's see the limit of this function when x tends to minus infinity. This also leads to infinity over infinity, so we can also use L'Hopital's rule. We derive the numerator alone, the denominator alone. We have to derive it again because we also have infinity over infinity. And in this case, we get minus infinity. So notice that L'Hopital's rule could be applied successively. So we can apply it more than once. Okay, try to find the following limits, please, using L'Hopital's rule. Now let's go on to Rami, Amir, Rima, or Mira. Now we have the 4 students at the same time. Now the question is to find the limit of this function as x tends to 2. Rami, I will use the leading term method. So the limit of this quantity is the limit of x squared over x squared, which is 1. Amir, I will use the simplification method. So the limit of this function as x tends to 2 is the limit of x into x minus 2 over x plus 2 into x minus 2. Then by simplifying x minus 2 from the numerator and the denominator, this becomes the limit of x over x plus 2, which is 1 over 2. Now Rima, I will use L'Hopital's rule. The limit of this function as x tends to 2 is the limit of 2x minus 2 over 2x, which is 2 over 4, which is also 1 over 2. And Mira, I will use L'Hopital's rule successively. This is the limit of this quantity. This is the limit of this function as x tends to 2, which is the limit of 2x minus 2 over 2x. We derive the numerator alone and then the denominator alone. We try to derive again using L'Hopital's rule. We get the limit of 2 over 2, which is 1. Now the question is, what do you think about the 4 methods? We have to ask ourselves the question, when do we use the leading term method? In fact, we use the leading term when x tends to infinity. So x in this case tends to 2, so we cannot use the leading term method. So this method is not correct. Now, the question here is, when do we use the simplification method? Now we can use the simplification method if x tends to a certain point, and in this case x tends to 2. But we have also another condition, which is the limit should lead to one of the indeterminate forms. And in this case, if x tends to 2 and we substitute 2 here, we get 4 minus 4, which is 0, over 4 minus 4, which is 0. So this limit by substitution leads to 0 over 0. So we have the two conditions. X should tend to a certain point, and it is applied here, and the limit should tend to one of the indeterminate forms, and it's also correct here. So this method is one of the correct methods. Remember, we use L'Hopital's rule when we have f of x over g of x, and it is applied here. And when the substitution method leads to 0 over 0 or infinity over infinity, and the substitution here also leads to 0 over 0. So we can use L'Hopital's rule. Now here, Rima used L'Hopital's rule, and here, in this second step, if we substitute 2, we get 4 minus 2, which is 2 over 4, and this is 1 over 2. Now the question is, what is the mistake in Mira's method, although we can use L'Hopital's rule? Mira used L'Hopital's rule successively, and in fact, in the first step, we can use L'Hopital's rule because the limit leads to 0 over 0. But in the second step, we cannot use L'Hopital's rule because the limit doesn't lead to 0 over 0 or infinity over infinity, and it leads to 2 over 4, and 2 over 4 is a constant and its limit is itself. So we can say that Amir's method and Rima's method are both correct, whereas Rami's method and Mira's methods are not correct. Thank you.